Continuing on with example 4 here, we're going to simplify this expression. If we look, I have a base to an exponent, and here I have a product to an exponent. So I have a power to a power and a product to a power. So we're going to kind of combine what we did earlier in section 7.3. Here when I have one base with two exponents, I have a power to a power, and I multiply my exponents. So I have half times 10 over 1. Okay, multiply straight across with our fractions. 10 over 2 gives me n to the 5th power. Now, with my product to the power, I take each factor, or each thing multiplied together, and give it the exponent. So I take 4 to the 3rd power, I take m to the 3rd power, and I take n to the negative 2/3 power to the 3rd power. Here again, I have one base, two exponents, so I have a power to a power, multiply those exponents. Negative 2/3 times 3 over 1. Multiply straight across. Negative 6 over 3, which gives me n to the negative 2nd power. 4 here, I just take to the 3rd power, so 4 times 4 times 4 is 64. And m cubed comes down just as it is. Now, these are also multiplied together here. So right now I have n to the 5th power times 64 times m to the 3rd power times n to the negative 2nd power. Now that I am simplified as I can with my exponents, remember exponents come before multiplication, now I can do my multiplication, and I can multiply together powers that have the same base. But again, here they have to have the exact same variable part. So I can take n to the 5th times n to the negative 2nd, add my exponents and keep my base, n to the 3rd. So here I have 64, I just dropped that down. My m I'm going to drop down into my answer, and my n I'm going to bring over n cubed. And these are all just multiplied together. This whole time all we've been doing is multiplying and simplifying. So 64 m cubed n cubed is our final answer there as far as a simplified expression. Now, what is the simplified form of each expression? Feel free to pause here and give these a try if you'd like. Right now we have two separate things. We have a product to a power and a power to a power. So power to power is because we have one base, two exponents. We have an exponent on top of an exponent. We multiply those when we have a power to a power and get x to the negative 4th power. Now, my product to a power, I have to take each factor in my product and I give it the exponent to each factor. Now I can simplify. 3 to the 4th power is 3 times 3 times 3 times 3, or 81. And again, we're just multiplying here still. X to the 4th power is just x to the 4th power. And here with my y's, I have one base, two exponents. I have an exponent on top of the other one, power to a power, and I multiply those. 5 times 4, which gives me 20. Okay, our final answer here. We have to combine our same bases. So now that all we're doing is multiplying, I can combine anything that has the same base by adding our exponents. So I'm going to take x to the negative 4 plus 4. Get x to the 0. And we know that anything to the 0 power is just 1. So right now, I have 81 times 1 times y to the 20th power. We know that 81 times 1 is just 81. So 81 times y to the 20th power. In B here, I have a power to a power, and I have a product, or something that's multiplied together, to a power. With our power to a power, we have 1 base, 2 exponents. We multiply those together and get c to the 6th power. With my product to a power, I take each factor in my product, so each thing multiplied together, and give it the exponent. So 4 there and 4 here. 3 to the 4th power, again, we said was 81. Here, again, power to a power, I'm going to multiply those exponents. So I multiply straight across. 5 times 4 is 20. 2 times 1 is 2. And that simplifies down to just c to the 10th power. And I bring down my c to the 6th power. Again, now that we're just multiplying, anything that has the same base I can combine. When I multiply those, I add my exponents and get c to the 16th power. Okay, here we have a product to a power and another product to a power. So before we can simplify here and combine our a's, we have to get rid of the exponents. PEMDAS says parentheses first. There's nothing we can simplify within our parentheses, and then exponents. So we've got to get rid of our exponents. Here in my first product, in my first factor, I'm going to take each individual factor there, 6, a, and b, and give them my exponent, 3, 3, 3. 6 cubed times a cubed times b cubed. I'm going to do the same thing in my second product here. So I'm going to take 5 and a to the negative third and take them both to the 2nd power. I'm going to simplify what I can. 6 cubed is 216. 5 squared is 25. Power to a power means I'm going to multiply my exponents. Negative 6. 1 base, 2 exponents. We have an exponent raised to an exponent, so we multiply those and I get negative 6. Now, all I'm doing is multiplying. So we're to the PEMDAS step where it says we can multiply and divide same time left to right. So I'm going to multiply together my numbers. Here, I get 5,400 because, again, we're still just multiplying. I'm going to multiply together my a's. A to the 3rd power times a to the negative 6th power. Because they have the same base, I keep my base, add my exponents. And then I still have a b cubed that I can't simplify at all. Still not completely simplified here, guys, because we have a negative exponent. We don't want to end with a negative exponent. So I move my a third to the 3rd power to the denominator. My 5,400 stays where it's at. My b cubed stays where it's at because it's positive exponent. My negative exponent moves to the denominator. And that is my final answer. Example 5 is raising scientific notation to power. The expression 1/2 mv squared gives the kinetic energy in joules of an object with a mass of m kilograms traveling at a speed of v meters per second. What is the kinetic energy of an experimental unmanned jet with a mass of 1.3 times 10 to the 3rd kilograms traveling at a speed of about 3.1 times 10 to the 3rd meters per second? So, our kilograms, it tells me, is m. Look at our labels, they're the same. Our meters per second, it tells me, is v. Look at our labels, they're the same. This one's written out, this is written in abbreviated form, but they still mean the same thing. So I'm going to take my formula, 1/2 mv squared, and I'm going to substitute in what I know. Again, we said our m is 1.3 times 10 to the 3rd power. And our v, meters per second here, is 3.1 times 10 to the 3rd power. And that v is squared. First thing, again, we have to do is get rid of our exponent, our product to a power, by taking each piece here squared. each factor, each thing that's multiplied together, gets the exponent from outside the parentheses. Here, since I don't have an exponent, I don't need those parentheses since all I'm doing is multiplying. My exponent is 1, so I can take each thing to the first power and get itself. Now, I'm going to take my number parts together and multiply them. And then I'm going to take my power parts together and multiply them. Here, I'm going to get 1.2 times 1.3 times 3.1 squared. Here, I'm going to simplify my power to a power. 3 times 2 is 6. And now this and this power, both my powers here, have the same base. So I keep my base and I can add my exponents and get to the 9th power. Final step here is just to multiply. I'm going to take half times 1.3 times 3.1 squared, and I'm going to get 6.2465 times 10 to the 9th power. If we look here, it's already in scientific notation because we have exactly one number in front of our decimal. So I keep it as it's written. If we wanted to, we could do 6.2 times 10 to the 9th to keep it similar to what we have here with one digit after our decimal, and that's in joules. Now, what is the kinetic energy of an aircraft with a mass of 2.5 times 10 to the 5th kilograms traveling at a speed of 3 times 10 to the 2nd meters per second? Again, our formula is half times mass times velocity squared. My mass is in kilograms. And my velocity is in meters per second. And again, we have to square that. Again, I'm going to get rid of any exponents I have. Here, I have a product to a power. So I have to take each factor and give it the exponent. I have a power to a power here, one base, two exponents, an exponent raised to an exponent. So I multiply those and get 10 to the 4th. 3 squared I also know is 9 off the top of my head, so I can drop that down as 9. The rest of this I can just bring straight down. I didn't change it, so I still have 1/2 times 2.5 times 10 to the 5th power times 9 times 10 to the 4th power. Again, I can take my number parts and multiply them together. And I can take my power parts and multiply them together. Multiplying powers with the same base means I keep my base, add my exponents. So I get the 9th power there. When I multiply my number parts here, I'm going to get 11.25 times 10 to the 9th power. My answer is not in scientific notation here. I can only have one number in front of my decimal. So I put my decimal where it needs to go, and I count how many places my old decimal was. Here it was one place, and I moved towards bigger numbers. So like if this is 0, this is a positive number, a bigger number. So I add 1 to my exponent. 1.125 times 10 to the 10th. And that's because if I have 1.125, I have to multiply by 10 to get back to the 11. So when I'm multiplying by 10 here, multiplying powers with the same base means I add my exponents. My answer here is in joules. Quick recap for section 7.3 here. Properties of exponents can be used to simplify a power raised to a power or a product raised to a power. To raise a power to a power, we multiply exponents, and to raise a product to a power, we raise each factor to the power and multiply. And that's all I have for section 7.3.